Welcome to this video where we'll be reviewing some of our fractional indices from previous classes. So let's get right into it and let's look at question number 1. So question 1 asks us to express the following in surd form. There's 3 questions there, and hence evaluate the value of each of them. So basically we've got these 3 numbers over here and we need to convert them into surd form. So just remember that anytime you see a power of a half, that is a square root. So 16 to the power of half is simply the square root of 16. If you'd like, you can put a little 2 over there to help you help remind you that it's a square root, but it's completely optional. So once you know you've got the square root of 16, you should know that square root of 16 is just 4, and that's the answer. If you'd like, you can actually check that out on the calculator. You put 16 and then power of 1 over 2 and then enter and you'll get 4. Awesome, let's try out now 27 to the power of 2/3. This time we've got basically a fractional index that's got a numerator and denominator, both which are not 1. So the way this one works is you use the square root sign, you put 27 into it, you put the cube root, and then the entire expression, which is in brackets, gets raised to the power of 2. And then you think, okay, well, what is the cube root of 27? That is simply 3, and then you keep the square over there. And once you have 3 squared, that is equal to 9. Okay, so that's pretty much all there is to it. Now let's go to the last one, where we have 32 to the power of negative 3/5. Now this one's a bit more tricky because of the negative power. But as always, we try and get rid of the negative power as soon as possible, which is what we're going to do. So to get rid of the negative power, I'm going to place the entire expression below in the bottom of a fraction, and then just get rid of the negative power. So we have 1 over 32 to the power of 3/5. And in the same way we looked at question B, we're going to convert 32 to the power of 3/5 into the 5th root of 32. It's the 5th root because the bottom number is 5. So that's the 5th root over there. And then the entire thing is going to be raised to the power of 3. So what happens now? Well, the 5th root of 32 is simply 2. The cubed remains there, of course. 1 over 2 cubed is 1 over 8. All right, that was a pretty tricky one. Let's double check that on the calculator. 32 power, use the grey negative, because that's negative, not minus. Negative, and then 3 over 5. Hit enter, and there we go, 1 over 8. Exactly what our by hand working gave us. Excellent. Moving on now to question 2. So question 2 says, simplify the following expressions, and we have got 5 expressions over here, all of varying levels of difficulty. So let's look at the first one. We have t to the power of a quarter, and then all that raised to the power of 12. Okay, so with questions like this one here, remember your third index law, which talks about a power inside and a power outside. It might actually be the 4th one, if I'm not mistaken. Anyway, it's one of the index laws where you have a power inside and you have a power outside. And what do you do with them? Well, all you need to do is simply multiply them. So we're going to keep the same base. The power is now going to be 1/4 times 12. Now, if you like, you can actually do a calculation on the side. 1/4 times 12 is going to equal 12/4, which is going to equal 3. So t to the power of a quarter times 12 is actually just t cubed. Excellent. Moving on to the next one. We have s to the power of 3/2, all raised to the power of 4/7. So again, over here, because we have a power inside and power outside, I'm going to multiply them. So 3/2 times 4/7. So again, we can do a calculation on the side. 3/2 times 4/7. I can cancel the 2 at the bottom with the 4 on the top. That becomes 1 and 2. And now we end up, right, let's just finish that off. So 3 times 2 is 6, 1 times 7 is 7, so we get 6 on 7. In other words, the final answer is just s to the power of 6 over 7. Excellent. And again, you can certainly verify that on the calculator if you wish to do so. Moving on to the third one, we have 16a squared b8 to the power of a half. So this one does require slightly more sort of work, and this is how we're going to do it. So first of all, 16 to the power of half, that is really just square root 16. A squared to the power of half, let's put that into brackets as shown. And finally b to the 8 to the power of half, again b to the 8 to the power of half as shown. Right, well, root 16, that's just 4, and now we have a to the power of 2 multiplied by half, and then finally b to the power of 8 multiplied by half. Okay, so now that that's done, let's do some calculations on the side. 2 multiplied by half, that's just 2 over 2, which is of course equal to 1. And then we have 8 multiplied by half, that's just 8 over 2, which is of course equal to 4. So how we do this is the 4 remains the same. A gets a power of 1, but that's invisible. Let's leave that out. And then b to the power of 4, and that is going to be our answer. Excellent. Moving to the fourth and final one. So part D, 64 m to the 6 n cubed and all raised to the 1/3. So this one is the cube root of 64. Let's fix that up a little bit. That 6 can be a bit better. There we go. And then we have m to the 6 to the power of 1/3, and then n cubed again to the power of 1/3, as shown. So the cube root of 64, well, that's just 4, and then we have m 6 times 1/3, and then n 3 times 1/3. Let's do a calculation on the side. 6 times 1/3 is 6 over 3, which is just 2. There we go. And then we have 3 times 1/3, which is 3 over 3, which is equal to 1. So what that means is we then get a final answer of 4m squared n to the 1, but the 1 of course is invisible. Let's just leave that out. Perfect. Here is the very final question of part 2. Okay, part E. We have a to the power of 2/3 over b to the 4/3, all raised to the power of 3 on 4. Okay, so again, this is just one of those types where we have a power inside and a power outside. So this is what happens. Let's draw the fraction line first, and then a to the power of 2/3 multiplied by 3/4. So you just multiply the inside and the outside powers. On the bottom, we have b to the original 4/3 power multiplied by the outside power, which is 3 on 4. All right, let's work these out individually. 2/3 times 3 on 4. We can cancel the 3's. The 2 at the top becomes 1. The 4 at the bottom becomes 2. So that's a half. And then we have 4/3 multiplied by 3 on 4. What do you know? That 3 and 3 cancels out. That 4 and 4 cancels out. So you just end up with 1. So what that means is our final answer is going to be a with a power of half divided by b with a power of 1, but of course power of 1s you can just leave them out. Perfect. So there we go. That first page of questions is, I guess, off a foundation level where questions like this shouldn't be too hard to proceed with. Right, the next two questions, numbers 3 and 4, they're a bit more involved, but just follow along, and if you do the questions at the same time, you should be able to get pretty good at them. Alright, so now with number 3, it says express the following expressions in appropriate index form, and hence simplify. So what that means is we've got these what we call surd expressions, all these square roots, cube roots, and fourth roots everywhere. So the best way to do it is to keep the number inside the root. So I'm just going to keep root 25 as root 25, but s to the 4, I'm actually going to raise it to a power of half. And why is that? Well, because we know that the square root is same as a power of a half. Okay, so that's very important to remember. So that is what's going on. Okay, so the square root of 25 is just 5. And then we have s. Now we have a power inside 4, power outside half. So what that means is we have 4 times a half, which is 4 over 2, which is equal to 2. In other words, we just have 5s squared. Not too bad. That looks pretty good. Let's change that to green. Okay, so now that that's going on, let's move on to the next one. So we have the cube root of 125. I'm going to keep that as it is. Cube root 125. But t to the 12, I'm going to raise that to the power of a third. Okay, and the reason behind that, as before, a cube root is the same as a power of 1/3. Okay, so cube root of 125, that is just 5. And then t to the 12 to the 1/3. Again, let's do a calculation. 12 multiplied by 1/3 is 12 over 3, which is just equal to 4. So we have 5t to the power of 4 as our final answer. Right, moving on to the last one of number 3. We have the fourth root of 16, and then x to the 8 raised to the power of a quarter. And again, that is because the fourth root of anything is just the same as the same thing raised to the power of a quarter. Alright, so fourth root of 16, that's just 2, and then x to the 8 to the power of a quarter. Let's calculate. 8 times a quarter is 8 over 4, and that's equal to 2. So that is just 2x to the power of 2, or in simpler terms, that's just 2x squared. Excellent. Now let's move on to the last section. Now this last section is a bit more tricky because it involves expressions being multiplied together. And when expressions are multiplied, remember your first index law, you got to add the powers together. So adding these powers together involves adding fractions, and adding fractions can be a bit tricky depending on the actual numbers and denominators. Right, so let's just jump right into it. So for A, we have y to the 2/3 times y to the 5/3. So this one, I'm just going to rewrite it as y to the power of 2/3 plus 5/3. Because remember, when you multiply two expressions with indices, you got to add the actual indices themselves. So what is 2/3 plus 5/3? Well, the good news is that both denominators are the same. They're both 3, which means you just create a single denominator of the same, which is 3, and you get 2 plus 5, and 2 plus 5 is 7, so the answer is 7 over 3. So the final answer is y to the power of 7 over 3. You can double check that on the calculator, of course. So you can take y and raise that to the power of 2 over 3, and then press right, times y to the power of 5 over 3. 5 divided 3, enter, and there we go, y to the 7 on 3, which is exactly what we had. Excellent. Let's move on to part B. So part B, this one is x to the 1/6 times x to the 2/5. So as we did in part A, I'm going to simply add the two powers together. But this time, the powers are not as simple as they were before. I have 1/6 plus 2/5. Now, 1/6 plus 2/5, they clearly don't have the same denominator. So what I'm going to do is I'm going to multiply the 6 and 5 to get 30, and then we're going to do a cross multiply. So that 5 is going to multiply by the 1, and that 6 is going to multiply by the 2. So we get 1 times 5 is 5, plus 6 times 2 is 12, so we end up with a fraction of 17 over 30. So the answer to this is x to the power of 17 over 30. Okay, so with questions like this, it's always good to have some working out space on the side so you can do these fractional calculations, because it's pretty hard to do them in your head. Right, moving on to part C. So in part C we have 12x to the 1/3 divided by 2x to the power of 12x to the 1/3 divided by 2x to the power of a half. Right, first things first, I can actually cancel the 12 and the 2. That becomes 6, that becomes 1. Right, not too bad. So we know that we have 6, but also we have basically two terms being divided. So remember in your second indexed law, when you have two things divided, you got to subtract the powers. So we know we're going to get 6x to the power of something. What is that something? Well, that's going to be 1/3 minus 1 on 12. Now, 1/3 minus 1 on 12, that is just equal to, now this is where you have to be a bit careful, with 1/3 minus 1 on 12, because the 3 and 12 actually have a common factor, you can actually get 12 from 3. You don't need to multiply 3 and 12 together. You can just put the largest of the two, which is 12, and then the top of 1 over 3 is going to be 4. And how did I get that? Well, all I did was, to get 3 to 12, I needed to multiply by 4. So multiply the bottom by 4, and multiply the top by 4 as well. So the 1 becomes a 4, and the 1, well, that just remains 1. So 4 minus 1 is 3. Oh, wait, check it out. 3 over 12, that is just 1 on 4. So 1/3 minus 1 on 12 is just 1 on 4. In other words, the answer is 6x to the power of a quarter. Or you can rewrite that as 6 times the 4th root of x. Right, that was pretty full on. Of course, it was made more full on because of the fractions, but just basic index laws as always have been done. Right, moving on to part D, the second last one. So part D, we have 3x to the half, y to the third, multiplied by 4 to the x 3/4, and times y to the 4/5. Okay, again, this time we have multiplication. So let's multiply the numbers first. 3 times 4, that is 12. And then when the x's multiply, you simply add the powers. So it's x to the half plus 3/4. Then we have y to the 1/3 plus 4/5. Right, so what we're going to end up with is 12x to the power of something, and then y to the power of something. So let's work out what those somethings are. So half plus 3/4, half plus 3/4. This time our fraction is going to be divided by 4, so we're going to have a 4 on the bottom there. Right, so what's going to happen? Well, the 1/2 is the same as 2 on 4, so that becomes a 2, plus 3 on 4, well, that's just 3 on 4. 2 plus 3 is 5. So we get 5 on 4, so the x power is 5 on 4. Now let's see what the y power is. That's 1/3 plus 4 on 5. Well, 3 and 5 are the denominators, so I'm just going to multiply them together to get 15. And let's do some cross multiplication. The 5 is going to multiply by the 1. That 3 is going to multiply by the 4. So we're going to end up with 5 times 1 is 5, plus 3 4s are 12. 5 plus 12 is 17, and that's divided by 15. So our final power for y is 17 over 15. Perfect. That is our final answer for part D. Alright, now for the lucky last. 2a to the half, b to the 1/3, over 6a to the 1/3, b to the half. Alright, first things first, let's cancel 2 and 6. That's 1 and 3. So 1 and 3 there. Then we have a to the half over a to the 1/3. So let's work that out. We should get a 1 on the top. I'll just leave the 1 blank. So we have a to the half minus a third, and then b to the third, b to the 1/3 minus half. Okay, and then on the bottom, we simply have 3. Right, let's work out what those powers are going to be. So half minus third, 2 times 3 is 6, that's your new denominator. Let's do some cross multiply. 3 times the 1 gives us 3, and then 2 times that 1 gives us 2. So we have 3 minus 2 over 6, and that is just going to be 1 over 6. So what that means is we have a to the power of 1 on 6. Then we'll get b to the power of something. Let's find out what that something is. 1/3 minus half. Now our denominator is going to be 6. So taking that 2 over there, we're going to have 2 minus, and that 3 is going to go up there. 3 times 1 is 3. So you get 2 minus 3 over 6. Ooh, that's a negative. We get negative 1 on 6. Interesting. And then that's divided by 3. Now if you look back at the original question, number 4, it says, simplify the following, ensuring answers are expressed with positive indices. Okay, so that's very important. Our final answer here has a negative power. We have negative 1/6 there. Right, so just recalling your rules from 1.3, how do you deal with negative powers? Well, it's not too bad. You just keep everything else the same, and whatever has the negative power jumps to the bottom and loses the negative power. And that's exactly what's going to happen. So b to the power of 1 on 6. And there we go. Our final answer is a to the 1/6 over 3b to the 1/6. Excellent. So that is the end of that fractional indices review. Hopefully all those questions made sense. If there's any questions, please don't hesitate to ask. Otherwise, jump straight to the exercise. Good luck with all the questions, and see you next time. Bye-bye.